Fitting and fixtures in water conveyance system. Fittings are nothing but these are fixed lines in the plumbing system to join the straight pipes or giving a section to different types of tubes. Now we can say fittings can be in different ways such as elbow, T, sockets, reducers and so many other things. These are usually used to change the direction of the flow and distribute the water supply from the main pipe to the other pipes. These totally depend on the type of pipes and material of the pipe. Next is water fixture. A water fixture is an exchangeable device which can be connected to a pumping system for delivery. Now the most common type of plumbing fixtures are faucets, sinks, bathtubs, showers, toilets. Each of these fixtures that we are provide, they will be having different types of valves, either to shut or to stop or to monitor the flow of water. These are installed in every water supply line which can lead to a fixture delivery and drain water. So that's why it is one of the most important component in the conveyor system. Next is we have to understand sewer joints. Sewers is nothing but an underground conduct or a drain in which sewage is conveyed to be flown from a point of discharge or to dispose. So there will be different types of joints involved in a sewer. So which are bell and spigot joint, collar joint, simtex joint, flexible joint, or we can say bituminous joint, mechanical joints and open joints. So these joints are very much important in order to let the sewer joints or sewer lanes in the proper way. For that we have to understand few things. This is pictures of some of the examples. First one will be a bell and subcon joint. Next we are able to have mechanical joints, and this is based on a sectional view for a bituminous joint. So these are all pictorial representation of the joints. Next we have to understand the cross-section view of a separate sewer in terms of understanding the internal and the external components. This is an cross-sectional view for a separate drain. As we were studying in the conveyor systems, how many types of sewers are there. So there are three types: partial, combined and separate. So this is a cross section for a separate sewer. So as you can see over here, we are able to have a street, then below the street we are placing the manhole cover, and then we are constructing based on different types of ladder types. These are having their own specific dimensions which we are going to study in the following class. So as you can see, this is a separate sewer. First one is the outlet has been given for a storm pipe, then we are giving for a sanitary pipe. So based on different types of standards, we are going to design this. This is just for your reference, for your understanding. So this is an example for a combined sewer. You can see a 4 mm concrete wall, then you are having a sewer where both storm as well as sewage drain will be coming out from here. Then we are having branch sewer. So this is just an half section and sectional view of the combined sewer. Now let us understand about design and construction of manholes. Why manholes are very much important. So to understand the flow of the water, whether the sewer is clear of any of the coagulations or whether there are harmful gases are getting emerged from it. To check that whether it is moving in a right and sequential manner, we require manholes. So as you can see in the left side, we are able to have a diagram over here. This is just a cross-sectional view. It is more elaborated, but it is easy for understanding. So let us understand manholes are just constructed using durable materials such as concrete, brick and composite materials. We are having a cover or a lid for a manhole which is designed to withstand the weight of pedestrian and vehicular traffic, whatever is there moving over it. So it is also having a locking security system for cleaning purposes and so many other things. As you can see in the diagram, there is some plastic chamber over here. Then we are having 150 mm of concrete surround, then motor joint. Then we are having a benchings which is about having 1:30 fall. Then we are having a concrete pipe beneath. Then we are able to have construction joint. Then we are able to have steps, and we are able to have covers and so many ladders. So this is just an understanding of your manholes. So why do we need manuals? Manuals are nothing but we are checking the sewage line whether it is clean and getting rid of any blockages if there is there. Next, with the help of manholes we are able to see the pipes or whether they are joined together or they are turned around or they are put in the right places. So sometimes these covers with holes also let escapes helps us to escape certain bad gases that have been composed because of the sewage. And with the help of manholes, the sewer lines can be laid at right length. So that's why it is very much needed to construct a manhole. There are types of manholes. Shallow manhole is something that is relatively shallow compared to standard manholes. These access underground utility systems based on sewer lines and storm. Based on this, they have less depth than the standard manholes. They allow quicker access, and the areas where the deep access is not required, we are using this constraint. Next is deep hole. This is deep manhole is nothing but a vertical shaft or a opening that is provided to access certain utility system. So this its depth can vary more than 50 feet depending on the infrastructure and the location that has been made. Usually we use this in tunnels and different types of industrial settings. Sometimes we are having certain safety protocols for the workers when they are confined to space risk. So that's also related to a manhole, deep manhole. Next we are able to see normal manhole. So this is very important because a normal manhole is also called as a utility or a maintenance hole, which will be covered opening in the street or sidewalks. Based on that, we are able to see different types of underground utilities such as sewer lines, storm drains, telecommunications. So they are typically made of cast irons and concrete, and they are also designed for a heavy load, and also they are usually covered very tightly to block the unauthorized access towards them, because it's very since it is mostly used and it is having all sort of emissions of severe gases and all. So that's why only a particular trained people are allowed to access and clean those kind of areas. And there are essentials for inspection, maintenance and repair of urban infrastructure. So we usually opt for normal manhole. The design of manhole, you can see first we require an access shaft, which is a top portion of a manhole, and it provides access, and it consists of a vertical chamber of 0.5 mm into 0.6 rectangular chamber having a diameter for a circular manhole will be 0.7 meters. In case of a rectangular manhole, we are able to see there is the axis will be corbelled inwards by three sides. So based on this, there will be it is done to provide a proper access by reducing the size of the chamber to the opening of the frame. Next, for circular manholes, the shaft is always slanted inwards. So based on this, the chambers have been designed. Next is the working chamber. This is a lower portion of your manhole, and it provides actual working space for carrying out the inspection, repair and maintenance activities that is going on there. Next, the working chamber of a manhole is usually larger than the axis of the shaft which is provided. The minimum diameter of a working chamber is for a circular manhole is 1.2 meters. For rectangular manhole, it will be around 1.2 meters into 0.9 meters. So the size of the rectangular manhole should not be less than 1.2 meters into 0.9 meters. This is noted that the larger dimension is always directed towards the flow of the flow. Next, the height of the working chamber should not be less than 1.8 meters. And since our working chamber is larger than the access shaft, the working chamber is constructed by enlarging the bottom portion for the access shaft. So this offset is usually constructed by the brick or RCC slab, which will also help to enlarge the portion and the access for the shaft. Next is the base and side walls. So base of the manhole is mostly constructed by a plain cement concrete. This actually prevents the progress of the whatever the water is coming through the underground water inside the chamber. It will be supported by these walls. So the bed of this concrete may also be reinforced to provide additional strength, and the minimum thickness of the concrete bed will be not more or not less than 15 centimeters for the manholes up to 0.8 meters deep, 23 centimeters for the manhole of the depth of more than 0.8 meters to 2.1 meters. Then we are having 30 centimeter of manholes to more than 2.1 meter deep. So this is about the base of the sidewalls. Next we are able to see about the invert bottom. So invert bottom is sometimes a semicircular or U-shaped channel of the cement concrete. The diameter is kept at the same as this sewer. These sides of the channel are extended vertically and above the horizontal diameter. They are kept nearly to the ground. These edges are often round and slope towards the channels from the benching. So the benching can range from 1 to 10 or 1 in 6, whatever the slope that we are providing over there. The benching is very much important as it drains the water, drains the water towards the sewage. Sometimes when two or more sewers meet at the same manhole, certain additional channels may be also provided, and that time based on the benching only we are able to provide those kind of intersections. So that is what we are going to say. Similarly, it goes with the ladders. Ladders are nothing but these are the steps that we are provided for the entry of this experienced and professional workers who are they will be using these steps which are usually made of cast iron. They are staggered at a horizontal center to center distance of 38 centimeters and vertical center to center distance of 30 centimeter. So based on the desirable place of the uppermost step is 45 centimeter. Below the manhole cover, the lowermost step will be less than 30 centimeter above the benching. Lastly, we are able to have a manhole cover and a frame. So this is an opening for a manhole. This is provided to a set of covers in a frame. The opening of the manhole is circular, or so circular covers are made of cast irons are commonly used, and the frame should be preferably 20 to 25 centimeters high, and the base should be around 10 to 12 centimeter wide. The total weight of the cover should include the frame range, that is 20 to 270 kgs. The frame is generally laid in a mass of cement concrete in a plane of which is aligned so that it does not interrupt the traffic flow. Thus, the topper surface of the cover is usually provided with a small projection to make it rough. This is done to ensure the surface is not too slippery. Construction is simple, that we are able to have a different size of manhole we have to determine based on the location. It must be noted that the size of manhole totally depends upon the diameter of the pipe, depth of the road level, and the crown of the pipe. Then a suitable type of construction should be decided. Excavation of the ground is carried out at the site, then compaction can be required depending on the type of soil. Next step is we are involving the laying of the foundation. Then later the walls of the inspection chambers are constructed and benching is formed. Roofing of the inspection chamber is done and the cover is been provided. So first one is excavation. Next we are able to have over here benching has been done. Then we are having laying of the bricks. Then you can see the cover. So you can see in the right side, this is how the finished manhole would look. Lastly, we'll understand about laying of water supply pipe. First of all, pipes are installed underground but can be above the ground in open areas. Certain times the process involves a detailed marking of pipe routes existing on the infrastructure, positions of different types of walls, and what all the things that are required for that conveyor system. We are going to have a detailed record of that. After that, we go for a center lines which are marked on the ground with the stakes at an interval. These trenches are excavated with the widths of 30 to 45 centimeters wider than the pipe diameter and extra depth for jointing. So the pipes are laid at least 90 centimeter below the ground for stability. Excavated soil can may need protection with the timber planks, and the pipes are lowered into trenches starting from lower to higher levels with the socket end upwards. Jointing of pipes is done during the installation process only, and the pipes are tested for the water leakage and pressure. And backfilling is also done with the compacted of the surplus soil. Then later it has been disposed of. So, laying of a pipe, it has various steps, but these are the general steps that we are going to provide. So, for your understanding, trench width, trench depth, protection of soft soil, joint depth, and testings are the most important thing that you have to know. Trenches should be always around 30 to 40 centimeters wider than the external diameter of the pipe, and trench depth should be at least 90 centimeter below the ground to prevent the damage from the heavy traffic and from the external sources. Protection of the soft soil is done by when it should be protected by the timber planks because to prevent any inward collapse. Next, we are able to have joint depths that should be around 15 to 20 centimeter deeper for 1 meter length. This is in order to facilitate easy piping. Lastly is testing. After laying the pipes, they should be tested for water leakage and pressure to ensure there are no that they does not cause any weakness to the system, and there are no leaks and cracks developed. This is just an example and view of a trench width. So you can see it is 150 to 300 mm from the cover. Next, we are able to have the diameter, then the haunch zone, bedding, foundations, initial backfill, final backfill. We are having pipe zone, then primary and secondary. Based on the native soil, this has been given a foundation. That's all for today's class. Thank you.